I'm going to talk about electron configurations of atoms in their ground state. Before I do that, here's a quick summary of the four main subshells and their orbitals. The angular momentum number L of the S subshell is 0. There is only one orbital, and the magnetic number ml is 0. Recall that the ml value can range from minus L to plus L. Here, the only option is 0. L of the P subshell is 1. There are 3 orbitals, and ml can be minus 1, 0, plus 1. L of the D subshell is 2. There are 5 orbitals, and the ml can range from minus 2 to plus 2. The angular momentum number L of the F subshell is 3. There are 7 orbitals, and ml can range from minus 3 all the way to plus 3. Now you might ask, what is the maximum number of electrons for each subshell? Well, Pauli's exclusion principle states that no 2 electrons in the same atom can have the same set of quantum numbers. In effect, this means only 2 electrons per orbital. So, the S subshell has 1 orbital, therefore the maximum number of electrons will be 2. The P subshell has 3 orbitals, 3 times 2 is 6, so maximum number of electrons is 6. D has 5 orbitals, 5 times 2 is 10. F has 7 orbitals, 7 times 2 is 14. Now that is all well and good, but how do we know which orbital is filled first? Your intuition might say that it would be the one with the lowest energy level, and you would be right. This is known as the Aufbau principle. Aufbau is German for building up. So these two boil down to 2 electrons per orbital, so that is according to Pauli's exclusion principles. Sorry, Pauli's exclusion principle, not principles. So 2 electrons per orbital. And the Aufbau principle tells us that lowest energy level will be filled first. So lowest energy level first. The next question might be, which one is the lowest energy orbital? An energy diagram might help here. So here's one that I prepared earlier. The energy increases as we go up. These integers 1, 2, 3, 4, 5, and 6 are the values for the principal quantum number n. And each orbital is represented by one of these horizontal lines with the ml value for each given up here at the top. Initially, the energy of the orbitals increases intuitively with the rise in the principal quantum number. So we have 1s, 2s, 2p, 3s, 3p. However, past 3p, things become a little bit messy, but that is a topic for another day. Let's do a few examples first. So we're going to start with lithium. So lithium has 3 protons and therefore 3 electrons. Where would they go? Well, we would start with the 1s orbital because that is the orbital of the lowest energy. So 1, 2, 3. Fairly straightforward. The next one is beryllium. Beryllium has 4 protons and therefore 4 electrons. So we would go 1, 2, 3, 4. The next one after beryllium is boron. It has 5 protons and therefore 5 electrons. 1, 2, 3, 4, 5. After that, we get to carbon. Carbon has 6 protons and therefore 6 electrons. So once again, we will go 1, 2, 3, 4, 5. And now you have a bit of a conundrum. Where does the 6th electron go? It could go here, or it could go here. Well, as it turns out, it goes here. So it occupies the next 2p orbital. This is due to Hund's rule, which states that the lowest energy is obtained when the electrons of the degenerate orbitals have the same spin. This word degenerate simply means orbitals of the same energy. So all of the 2p orbitals are of the same energy, and also all of the 4d orbitals are of the same energy. Anyway, let's keep going with our examples. So after carbon, we have nitrogen. So nitrogen has 7 protons and therefore 7 electrons. 1, 2, 3, 4, 5, 6, so we are obeying the Hund's rule, and 7. Next one is oxygen. Oxygen has 8 protons and therefore 8 electrons. So once again, we start with 1s. Then we go 5, 6, 7, and the 8th one now occupies this 2p orbital with the electron spinning down. After oxygen, we have fluorine. So fluorine has 9 protons and therefore 9 electrons. So we do the same thing. We start with 1s and we build up following the Aufbau principle, making sure that we obey Pauli's exclusion principle and also the Hund's rule. So we are up to, what was that? 1, 2, 3, 4, 5, 6, 7, 8, and 9. After fluorine, there is neon. It has 10 protons and 10 electrons. So once again, we fill up following the rules, and that is now 10. And I will do one more for sodium. So sodium has 11 protons and therefore 11 electrons. So we start with 1s and we go up, making sure that we obey our rules. 10 and 11 goes into 3s. That is all for now. Later I hope to talk about how do we write electron configurations in a more concise and condensed manner. Have a good day.